Hello everyone, welcome back to my YouTube channel. So in this video, we will be covering the second part of troubleshooting. So let's just quickly recall what are the things that we have covered in our previous video. So in the previous video, we have simply created our custom image for our sample application. So we created 3 sample applications. Let me quickly recall and show you what exactly we have done. So if I recall you in our previous video, we have simply discussed this part. We just created a Docker image for our sample application. We gave that name as red app, blue app, and default app. And we displayed, if you recall, we displayed simple web pages, which is having different colors and naming and display. And then we post a Docker image for that in Docker Hub. In this video, we will be covering the second part and we discussed in the last video. So in this video, we will not only be creating this spot and but all the other resources that are required slowly, one by one. So my objective in this video is to demonstrate you how we create our first spot from the Docker image, or that this part we already have covered in first part. So once we create a pod, what are the other resources that we can create? What are the needs for other resources like services, ingress? What are the needs for nginx ingress controller? What are the difference between deployment, replica set, etc, all this stuff? Because those are the basic stuff of Kubernetes and those are most frequently asked. I will not talk about theory much more in this part, but I will focus the troubleshooting part. The troubleshooting will involve basically whenever there's a issue with the Kubernetes terms, like pod is failing, application is having issue, there is lots of error. That part we will be covering as well in this video. And by this, I will be able to explain you how actually the Kubernetes cluster works and what is exactly the Kubernetes cluster having the flow in terms of API. So whenever a request come to the to create a pod, simply so what exactly is happening inside the cluster. How Kubernetes handles is first request to create a pod, delete a pod, or any API request from the user. So how it handles. So there are lots of resources in Kubernetes that it handles. So we will jump this on later part of this video, but our objective is to firstly create resources one by one and uh, try understanding the need for these resources. So let's quickly jump on. If you recall, I have used this sample application, basically these Docker files for creating the previous pages. So I just simply create a Docker container for each of these and just displayed these in my web page. So I was able to see different pages for each of the Docker file. Basically, this need was just to demonstrate like what are the different kind of application that can be deployed in the industries. So in actual industry, what happens is we have lots of different type of applications. So basically these are microservices based applications. So there are custom images, and then we use those custom images to create our application pod. So let's take example like we have Facebook. So we have in Facebook lots of pages, drop down options, photo option, posting option available. Earlier what used to happen is this complete deployment was done from one single code. Any changes in one single code can lead to drastic like production failure of the Facebook. But now what happens is there are microservices concept. So now the entire page is segmented into different parts. Like each section is having different code. Each team is handling that code specifically. So there's a code for bucket, for code for filters. So there are different coders working for that. And each segment is having the microservices concept behind that. So suppose if that filter part is not working, then there may be at the back end there's a filter pod or there's a card pod running that is having issues. So that can be separately handled. By that, there's a benefit like we can simply have the web page available and there's no production down scenarios in that case. So there are lots of other benefits like cost saving, time saving, etc, portability. So So just quickly come back, and in this I just tried to create 3 sample application just to demonstrate you again that there are there are application running in the companies like that, this scenario. So basically in any company the applications are running, there may be multiple applications. So in this video I will be telling you like I will create 3 different pods, and just like any standard company is having, there may not be 3 only, there may be more pods, but this is just for demonstration. Okay, and then we will be creating services and guess one by one. So let's quickly come back, and I just already reviewed this. This is our application code that we have already discussed in our previous part, first part of this video. Even if you are going to start this video from scratch, you don't want to visit the previous part, you can simply start from this as well. But the need is you have to have the basic configuration in your system and know that there's a custom image already available. So I have made the custom image available here, like in my Docker Hub registries. I post these images here. So these are app red, app blue. So if you see, these are public image. Just this one is app default is private. I have intentionally kept this private because I wanted to demonstrate you one more further level of troubleshooting, so it will be used at that time. I will give more about that later on. So let's continue. Um, so let's continue. I have this app code. All these things we have already discussed. Each of the HTML and then this Docker file. But I'm not going to use this in this case because I'm not going to more play on the Docker Hub Docker part. Basically, we are directly going to start with Kubernetes deployment. So let's close all these files. So now, for that deployment, I have to first create our first K8 cluster. So like yes, yeah, in the previous video, I have demonstrated you like we can simply create a Minikube Kubernetes cluster, Minikube start. So basically, there are lots of ways to create Kubernetes cluster depending on the requirement. I will not discuss more about this as of now because it's going to elongate the video too much. When we do Minikube start, it's simply create a simple Docker container. So it's basically running as a container. So before to that, you have to start your Docker engine in your system. So that's why before running Minikube start command, I open firstly this Docker desktop. As soon as I open this Docker desktop, it start Docker engine in my system. In the next terminal, let me try to demonstrate this. So if I run Docker PS, it shows like there's a Minikube container started. So basically, when I run Minikube start, so it is starting a container and as well as is availing of us a Kubernetes, simple Kubernetes cluster. If you see kubectl get nodes, it's just having simple one node, control plane node. Ideally, in standard production companies, there's a different scenario. Like we have either installed by kubespray, kubeadm, or there are another methods. So that depends on the user's company's requirement. Okay. So let's continue. We have this Kubernetes cluster. I'm not going to talk more about how exactly Kubernetes cluster look and create is pod. Pod is basically something, name which is encapsulating a container, one or more container. Pod is basically a virtual name for a container. It is something which is encapsulating one or more container. So inside pod, if there's a one container running, then there's just one container. So let's try to first create a pod simply. Now, pod can be created either by kubectl command line only or with manifest. So there are two ways to create pod. Like we can create by kubectl command line only, or we can create by declarative approach. In companies, we prefer declarative approach by manifest, YML file basically. So we can create a YML file to create a pod, and that can be done very easily. Like there is a simple method to create a manifest file. So if let's first try to create a pod. Same, if you remember, we created container with Docker CLI only. We can create a container with Docker file as well. So this is the CLI approach, this is declarative approach with file, or here in this case it's manifest with my YML file. So let's firstly create a container like Docker run hyphen. Syntax is like we just create so firstly we create a pod with the Docker run command, Docker run, name of pod, let's say app red, and then images like where we have this image is available. I have mentioned all these steps in readme file, or all these whatever I'm going to do in the readme file. It's going to be very easy for you. So you don't be panic about like how you can create this. So here in my Visual Code Studio, in this repo, that link I have already shared here. In this repo, the first step code I have already pushed this. I will push all these changes as well. So I have also mentioned these practice set, like you can just create a simply copy paste and then like let me app red image. So this is just a syntax. So basically I wanted to tell you like this is a syntax for creating a pod. It will run and name of pod, image, and then tag. So if you see like to give this tag like that, it says pod is created. To see the pod, you just need to run kubectl get pod. Now, sometimes you may not be able to see the pod because might have selected a different namespace, kubectl get pod, so it's running. So to see pods running in all namespace, you can just simply run -a option with that. You see, there are lots of pod you can still see. Now, what are these pods? These pods are basically running in the master node, basically in different namespaces. This is required by Kubernetes cluster. This is separate thing. Nginx ingress controller. I will tell you more about later on this. So we just created simply one pod. Now, what if I want to create a manifest for this pod? Get pod, let's say app red. You created app red. So if you want to get the manifest, why I'm telling you this step is, if you don't recall how to create a manifest, you don't need to remember all these steps in the manifest. You can either pick from Kubernetes documentation page the manifest YML file to create a pod, or if you should be having simply the idea what are the components there. If you don't remember, then simply you can create a pod from command line, and then only you can generate a YML file for this. So import this into a file as well, like this app red.yml. You can just give a name new, because I may have already existing. If you come here, if you see there's a app red new I created, this is having the component of the pod. So if you don't know how to create or how to write a manifest or YML file, don't be bothered about. You can just copy the manifest from Kubernetes documentation page. You just need to update those entries, like the basic entries, the name of pod, namespace. I just use default because I have not passed any namespace in the command line. And then image name, this is important. So basically few parameters like name, namespace, image name, and so in some exceptional case, the policies as well. Name of container. So like that. Now, you are good to see the pod. Now, if you just deleted this pod, delete pod, the command to delete is delete pod, add delete. And if you don't want to create a pod again, but now this time with manifest. So you have the command kubectl apply -f, and then app red new. I'm using this same manifest we just created, exported. Now you will say why we are doing this, like we just first of all created the pod and then exported this, and then again deleted the pod and creating the same pod from this manifest, because we can then in the meantime customize these changes. If you want to let me to see, I will simply uh, rename this and make another copy of it. So let's say new and then blue. So This is the benefit. So if you have just one single file, you can then replace this to a new pod to create new pod. So I just simply use this and replace all the occurrence of red to blue. So I will now create a pod with blue name, right? You can see, you can remove this status part. It's not you. In fact, you can just simply remove uh, other parameters as well. So the most important parameters is this API kind metadata. You can remove this. It is runtime generated. You can even remove this. And yeah, let's keep all this as of now. So you have another manifest here. The benefit of this is you are good to create a pod with existing manifest. You just need to simply rename the values. And now in the same command line, this is command to create any resource, not only pod, any resource, and the resource file name manifest here. If this is surveys, deployment, or etc you are going to create, you just need to pass the file name for this. But with a single file command line also, with a single command line, you can create different resource. So let's pass this blue new. So I am using -f 2 times because each time you have to pass the manifest resource file. If you see now, it has created pods, 2 pods. Now just dig about this pod to have a look like what it pod is. So describe, kubectl describe and pod name. Kubectl describe command gives all the metadata, all the information like on which node it is running, what is the container ID, etc. It is running status. This is very good command to important command to troubleshoot as well. Most of the time it gives failures. So you can easily see what are the failures like events here. In the event section, you can see what are the events happen there. Okay. And in some cases, you can see conditions. What is the condition? What status it is in error state or what it is? It is in ready state as of now. So these are the basic things you can play around with this describe command. So now we have 2 pods. We created this with manifest this time. Like that, we can create multiple pods. So again, now we only have this pod. Now we will further kept moving. We just created a pod. What are the requirement of deployment? Basically, deployment is something which is used, which is creating replica set and the pod, first of all. So now let's take example. If you deleted this pod, kubectl delete pod app red, it will be simply deleted. So suppose anyone came and simply deleted the pod, but if that pod is deleted, then application is down. There is production down scenario. So to avoid this, let's first create a deployment. So this is the benefit of creating deployment. Like if you create a deployment will further handle the creation of replica set and then pod. So basically in deployment, the difference is only, if you see the deployment manifest, let me give you an example of this. I have only the applications. Let's just create a deployment replica set. So we can create a deployment with command line, create deployment, and then app red, and then again hyphen image name. Let's keep this image name. I deleted red. Okay, it created a deployment. Now try to notice the differences. kubectl get deployment. This time you have to do get deployment. If you see get deployment, it's having 0 ready, means it's going to create one pod. Let's describe this. kubectl describe deploy app red. So again, it's having here scaled up replica set, and then it's having it's just trying to create a one pod. Let's try to see the pod now. kubectl get pods. So it's showing error. Good. This is something we will do troubleshooting. This is very important. So what I was trying to tell you is, if we create a deployment, now if we see the deployment manifest, again the same way we can get a fetch deployment manifest, get deployment app red -o-yml. So again I can just export with the arrow character, app red, let's say app red deploy.yml. So again, if I go here, I have this deployment. The only difference is having kind deployment type. Again, there are other differences as well, like here. It has these values, selector, strategies. These are to tell like deployment will create the resources further on, like a replica set. We can remove the status part. It is not no way required. And here the replicas. So with if I pass one replica, so the benefit of deployment is, by deployment we can control pod. If even if we have deleted pod and deployment is running. So let's do get all. If I run this command get all, it displays all pod services and deployments. So if you see, if we created a deployment app red, it created a pod. Though it is in the error error state, we will take it look later on about this, because this is the objective of this class. Like we will troubleshoot more about these errors. So it has created deployment app red, and then there's a pod created for this. So with this pod, it is also have the replica set. So basically, because of this deployment, even if we have deleted this pod, we can recreate it, because in deployment, the replica value, this value here, is set as 1. We can set it as per desired value. If it is set as 2, then it will create the desired replicas as 2, and here replica set as well. So basically the flow is like, deployment is creating replica sets, number of replica set as mentioned here, and then the same pod, number of pod are created. What is the difference here? The deployment is basically again a virtual resource which is handling to create pod. So we don't need to simply touch the pod. Even if we touch the pod, deleted the pod, deployment, because of deployment, it can be recreated as with the number of replicas, the values, it is there. Also, we can, if we want to patch the image, if we want to update the code and we have another image with latest tag there, so we can simply touch the deployment and apply there. Let's say let's do this. Now what I'm trying to do is, I will be touching this deployment and image here. That is the issue actually. Let's here. Now let's see two things. The image we saw, the pod is having error state. Let's take a look on this pod. Describe pod, and this we can just pass this name this way also, like a complete pod name and slash by the pod name, like this. So you see there's an error in the event section. It is saying full access denied for app red repository does not exist or may require Docker login. This is saying this app red repository does not exist. The reason why it's failing is because we have wrongly passed this here image name as let's see here app red here. Earlier it was app red, this like this app red, but it is not the image. There should be the complete image path. So it's like that. Red, for red it is red. So this is basically the complete repository and the image name and the tag, complete path of the image. If now take this as an example to create patch the pod. So this is the benefit of the deployment, like get all again. So since deployment is controlled, creating replica set, and then it is controlling pod. So the one example I told you, we can create add many number of replicas as we want because of deployment. If if there's only pod running, then it can be a problematic situation when any pod is deleted. Even if I want to patch any code or apply changes to the application or image, then it will recreate this pod. It will delete this pod. It will then recreate this pod. So by that, it will be an issue with the production down. So if we are doing this with pod only, it is an issue. But when we have the deployment there, we can easily manage the pod deployment, pod patching. We can manage the pod pad patching, counting, replica set, etc. So basically, because of deployment, if we are going to apply the patch here, now apply again here, app red deployment -f, then it is configured. See, again, don't bother about error. Now see, it is running. The same pod is applied. What happened is, this pod was running. If you see last ID LDCSF, now it is created with J5QL. What happened is, deployment meshed the replica count to 1 as defined here, and it created the correct image. So basically, it's just like applying patch. Next time we create another image from this, pod from this. So now we had not to touch the pod. That is the benefit. We applied the patch directly from deployment. So this saves the time, production down scenarios, like we can save this, avoid the production down scenarios, because when we applying the patch from deployment, it is doing in round robin way. Like it is firstly deleting the pod. I mean, it is firstly creating the pod, existing pod. Firstly, it is creating new pod and then deleting existing pod. That is the way new patch is applied by deployment. So that is the benefit of deployment. So there are lots of parameters that we configure, like a rolling update. Basically the rolling update strategy is there. So what it says is, it's firstly creating a pod, new pod, and then deleting the old pod, so that there's no production down scenarios. So in summary, we just see like what is the difference of creating deployment and then an only pod. So this is beneficial to manage all the pod from deployment. It's good. Now, we just covered creating pod, creating deployment. We can create another deployment. Let's say we just simply copy one more time this app red, and then rename it to blue deploy here. And then once this is there, we can again remove this name, like this creation timestamp is not required in any resources, whether it is a pod or service or deployment. And then now here change occurrence of red to blue everywhere. So we have new deployment created. Now it's just like applying a new patch. So we created another deployment file and then created another file. Let's do get all. It created another pod. It's just trying to create it. This will not be having error because we have correctly passed the image name here. If it is having issues, it now the point to note is here, it was throwing image pull back off error because the name itself says image pull back off, because it was not trying to pull it was failing to try to pull the image because the image was not existing. This is one category of error or pod status error state that is there to troubleshoot in many scenarios. So we have the two replicas here like that. So we have deployment running, we have pod running, and service. Now we will be heading to create service for this app pod. What is the requirement here? Again, we discussed about the requirement of deployment and pod. Now we will discussing a requirement of service. So basically service, what is service in Kubernetes? Service is something which helps to which helps application to talk to external environment. There are different type of services like load balancer, cluster IP, node port. So there are three type of service basically. And because of this, any application can talk to front end or back end. If it is a database or so if it is a cluster IP type, it should be supposed to talk with the back end database. In some scenarios, we don't want our applications to talk to external environment and should be talking to database only. So if it is a node port, then it should be talking to external environment. Any API user or front-end user can talk to that API. It's like that. It depends on the user's requirement, what service type they want to use. So now what is the requirement here? We created the sample application, but we cannot access it. If you remember last time, we created sample Docker image and we were able to simply access this with the local host and the port name with the web page, but it is not happening. Let's try to see. We have the pod running here. Pod is running with the port. Let's say we have not defined here, but we can do. So we have not internally defined the port, but pod is running, but we cannot access it with either of this port, 8080, because a communication is not allowed to talk to these applications. So here comes the need of deployment service. So with service resource in Kubernetes, we can enable the communication for these application to the external user or internal user, basically front end or back end. It can be database or front end. It depends on the service type. So that's the need of service here. So now we have to create the service. Again, service can be created by command line and by manifest again. So we can create a manifest file for service. Like I have some sample manifest running already here. So I have already defined these all stuff here. Like let's try to create a red app service. So this is service we can create from this manifest again. So we just simply pass in kubectl apply -f the manifest name. It will automatically connect to the application. How it is going to connect to the application pod? Basically, it will create a service with service name app red service and namespace default. Now then, because of selector field, it will look any application pod which is having the same label. So how we can see the label? kubectl get pods --, let's say so labels. So if you see these two bottom pod, let's try to delete the first pod. It's just giving a confusion with pod. Okay, clear. kubectl get pods so labels. So it's having labels app equal to app blue. So it service what will do come and search for any application pod running with the same label as mentioned in the selector field here. So basically it will come, it will see if there's any pod running with app red label. Okay, here it will see app red label. So it will connect to that pod basically. This connection is like that. Let me try to demonstrate this in the here. Yeah, it's just like this. We request, we are here, we created pod, we are going to create service. Service will connect to specific pod depending on the matching labels or selector. So service, in service, we mention selectors. This is important. In service, we mention selectors. And in pod, we match labels. So label selector is one concept in pod to select a specific resource. So in selector is going to select the applied labels. So service is having the definition of selector and pod is having the pod or deployment is having the labels of map. Sorry, the labels basically. These label only. Clear? So let's delete this deployment here. To delete this deployment again, from where we created the deployment, from whatever file we used, manifest we used, we can delete the deployment using the same file with this command, delete -f and app, let's say red deploy and -f again for second app blue deploy. So it has already also deleted all the resources. Like now you see there's no pod running, no replica set running, no deployment running. Now let's do from scratch. I will move to one directory first app because I have already this manifest defined here. So I want you to review this so that we avoid time to write these manifest one by one, because our objective is to understand all these resources and troubleshoot the connection, what is depending on what. So let's say I am not going to app code because app code is done already in the Docker, the concept part, the first part. In the second part, manifest, we have this, I have this, all these resources running. So their resources, let's say ls-th grep pod. So these are resources file for pod, and then there is a resources file for let have default to make it like that, default to pod dot file. So again, clear. Nothing but just I was trying to make it identical. So we have 3 pod manifest, 3 service manifest, and 1 ingress. I will come in picture to explain more. So let's quickly create the pod. I'm not going to create deployment as of now because already we discussed what is the need of deployment. In this case, we only just need to understand the thing. So there's no need to create deployment because it's just a demo scenario. So apply. Earlier, this command was create, but create fails when we are applying in the second time. So apply is good as of now because it's in the new version, apply is existing actually. So we just created 3 pod. Let's try to create 3 pod. Oh, sorry, I forget to mention -f for the third one. Okay. So basically it should be creating 3 pods. Let's say I was aware about this. This was exceptionally I kept in the private. The reason for this failure is because the third pod failure is because this is in private mode. This is in private mode. So that's why it's not able to pull this. This was intentionally kept like that because we were willing to troubleshoot it. This error status category. So again, let's clear this scheme. kubectl get pods hyphen not a this default namespace. If you simply do get pods, it will display the default namespace. If you do for a specific namespace, you have to mention -n, or let's say ingress nginx. If this exists actually, if this namespace exists, then it will show pod for this namespace. If not, if you don't pass this namespace, it will display for default namespace, which is default. Now, if you want to deploy this pod in a specific namespace, so you have to pass this namespace value here. Like let's try this same app, or you can say dev namespace. I have to apply this to all file. I want to deploy this app, this all 3 app to dev namespace instead of default. Dev, 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 dev. There are lots of changes I have to apply, but let's simply see what is the scenario. So here, if I want to apply the changes or I want to move all these resources to dev namespaces, how I have to remove this again. kubectl delete pod app blue app default in one command line. Also, we can do that. Red. Now, if we apply this, for example, let's first one apply -f, gives you apply -f app red pod. So app red pod is having namespace. It created. But if you see get pods get pods only. Okay, it is showing because something is okay. I applied in the red, but I created blue because red is still created in default, but I applied the changes in blue. So if I do kubectl apply in blue also -f, it will fail. Blue is having a dev namespace. Red was having default namespace. Red was created. It will fail because dev namespace does not exist. And we have mentioned is here dev namespace. So we have to firstly create the name namespace. To create dev namespace, we have command create, create ns dev. Name ns is for namespace, and dev. In short, we can just pass ns or namespace dev. It created, and now again apply. It created. So now we have pods app red running only in there, and dev having blue. Now you got the difference. So we can simply pass the namespace, but we have to have the namespace already running. Now, the same way we can create namespace either by name manifest. We can just generate a manifest to see how it looks like. Kubectl get ns dev -oyml. -oyml is basically to export the existing running resources. If it is for pod, for namespace, service, or etc. You can just see. API version is this one, Candice namespace, and then the label name is dev, this one. You can just copy this and create another namespace by replacing the name if you don't want to remember this manifest data, because it's hard to remember all fields, but it is important that in each of the resource, this is common. AKM, API version, kind, metadata, and inside metadata we have annotations, label, name, etc, and then spec. So this is basic like dictionary data type. AKM, and then saving for the resources is S, specification, where we have the value specific resource. If it is a pod, it has image. It is a namespace is a finalizer, like that. So let's revert the changes, because I'm going to apply this in the default mm, default. I'm going to create this in the default to save our time every time, because I have to pass, otherwise lots of values. Okay, so simply again create kubectl, create pod, app red, app blue, app default. Again, so I created pods. So it's creating. The second will fail again. Now I'm going to create service for this, because our objective was to point to service. Now let's review the service manifest. I created a manifest separately for each of the services. App blue services name is this one. It is having selector name app blue, so it will point to the app blue pod. Automatically it will be attached to app blue pod. And what is this? This is something interesting. Target port is something which is open at the container end. This port is something which is open at the service end. Let me try to show this from here. I have somewhere this document. Maybe not. You can easily see this somewhere. Let me see. Target port and port, like that. You just simply Google this. You can see this difference. So if you have this like target port is something which is, you don't be confused with this port number. Target port is something which is port open at the container end. Basically pod here. And service port is something which is running with the service. So basically here, port is something where service will be running. Service will open at 8080. And target port is something where pod is running. Pod is open at 80 basically. So this is simply nginx image which is already running by default at 80 port. So here now I will try to create kubectl, create apply -app red svc -app blue svc -app default svc. So 3 manifests for service, like here. Each is pointing to different pod. Default is having different selector, red is having different selector, but port is different. It doesn't matter, because anyway it's going to create different service. So it can have different port. Okay, there's some issue with the default service name. Here, this like that. Again, apply. If you apply in the already created, it will just simply say unchanged because it has not created. Sorry, I just applied in the pod. Here, it has unchanged the existing one or created a new one. Now you do CubeSheet will get all. So we have here, clear the screen. We have here pod, app read, these pods, and then the same way services running. I think with this one missing, blue. Why is not there? App read, CubeSheet. Let's try to. Oh, I think it is having still the dev namespace. Let's try to create CubeCTL. I apply -r app blue, or maybe having different name. Blue, no, blue SBC. Okay, we have blue. Okay, red is not created basically. Okay, red is not created because we have default namespace. It created but in different namespace. So let apply again. So our objective is to have all these resources in same namespace. We can have it in different namespace as well, but we will be easily able to dig all the issues in the initial chapters. Okay, we have 3 application, 3 service. Now we have created these services. Now, as I explained, the service allows us to contact to the application, to reach to the application. Because of service, we can reach to the application. But here, the issue is these are the private IPs. Even if I do open this in my local uh, browser, it's not going to work because it's not anyway mapped to these resources. So we have to first of all create one expose basically. Let me give you one more example. We created manifest, we created services using manifest. We can even create services using command line as well. So I mentioned all these command like just to create the services, we just simply need kubectl expose. Let's try to delete one kubectl delete one service and try to create with the let's say blue. Delete sorry as we see, and then blue deleted. Now let's try to create with the command. So what it is doing, it is trying to create node port type services as I explained you, and name is red blue. I deleted blue, so let's create blue, and it's going to the command. Look at the command kubectl expose deployment. So it's saying expose deployment means so that the deployment can be used by front end or back end user. So it can be reachable. But here I will be doing expose pod. Let's see. Okay, sorry, here the name is not there. Expose pod. So basically expose pod. Yeah, okay. I just passed the service name. It is not service name. It is basically the pod name which we want to expose. Now let's try to see. You see service app exposed. kubectl get SVCs. Let's try to see if it has made any changes. Okay. We deleted this SVC. It is deleted, but it is created with this name. Okay, no worries, but it is the objective is like we have different naming convention, so we can even pass, I think, a different name here. Doesn't matter. So basically, it is matching with the label of selector, and then it is creating. So basically, with the command line, we can create a service. That is the objective. So we created these two with the manifest and this one with the command line. So let's try to delete another one so that we have identical naming convention. Delete default as we see, and then try to expose this blue, red, and then I'm sorry, expose blue red and default. So now we have get pods, and as we see, we can do get the values like this with comma. So app pod, default red, and three services. I think this sheet will delete services and then expose with the what is left one? Blue, I think blue is left. Okay, now do clear the screen again. And now see, we have three application services running and three app default. Now, again, we have to expose these. I want these services to be used in the browser. To do that, I have to simply export this. I mean, I have to get Minikube IP. Let's try to see Minikube IP. If I use this way, it will not work, I'm sure. 80, let's say 80. Or simply say localhost 80. Okay, it's not going to work. To make it work, you have to export this. So finally, what we have done is we have created the application, we have created the services. Now the issue is in my local system, it is not going to work. For that reason, I have to expose this service again one more time. So there's a kubectl port forward command like this here. With this is a syntax basically. So this is any port you want to export, like 5001, whatever. So whatever port you want to export, like app red and the local host IP. So basically what it is going to do is it's just going to export this port to external port, which is already listening inside pod to 80, and then add to the local host. This is IP to the local host. If I do so, it's already occupied. Let's do this for app. Another port number, sorry. And then, so as you see, it's exported to for port forwarding. So basically, it's port forwarding. So basically, what's happening is the port 80 on app blue is exported now to 5002 so that we can access it in the localhost IP. So here, if you see 5002 exported for blue, and it is to the localhost address. You see 000 or the localhost 00000 or localhost, right? Like that. So then why we have created services? There's no need of services if we can export this using this method, port forward method. This is actually required because in a standard application deployment, we cannot use port forward because this is a security breach. We cannot simply export the application to any external environment. Anyone can, because no one is going to locally use that application. For that reason, we need service. This is a standard deployment. This is a standard procedure to deploy them. Now, before to make this available using services, we have another method. So we will first of all create ingress about that. I will explain why we need ingress. To create ingress, I already have this one common file. I have not created different file, just one common file for ingress. So I have defined here the path red and blue. So basically, what is ingress? Ingress resource in Kubernetes is something which is helping us to allow paths for common host IP. So because of ingress, if we have one application is running in different pod, let's say here, where one application is running app pod, it's having different purpose, second is running having different purpose, and the same way we have mapped sort of service, then we create a ingress. So when we create ingress, the kind is again same AKM, kind is ingress type, name, simple example ingress, or you can say app ingress, app ingress, And then here rules. So this is important. This as well, annotation as well. I will come later on this. The rules here is basically saying here is a host by which you can access, and if this host is provided with the path red, then you will go to this service. I have to rename this the service name because I have changed the service name. So basically what's happening here again, host is something I will be using as a common, and path is something where a specific application will be redirected. So if I will use /red, then application will be redirected to this pod. So this pod will serve the requirement, customer requirement or API request. If it is /blue, it will, the second blue pod will be referring. How it's happening? So if you have a close look on that, then path/red, path type is prefix type. So it's prefixing it. We are prefixing it. And backend is service. So backend is important. So basically, this ingress with this host is going to connect to backend service which is running with this app red name. So basically, it will come and search in the same namespace. If it is, oh, if there is any service running with app red, okay, it will find if there's an app blue service running, it will be attached, and then further service is already attached to the pod. So basically it's like this again. So each service is there should be multiple services. Basically in this demonstration I have just given one service. We can create one single manifest for service as well. So one service is connected to second app red is connected to app red pod, app blue is connected to app blue, and then here ingress is common, and there is the routing rules. Routing rules are basically these one. So this is something ingress is talking to service and service is talking to the pod. So here it will point to the app, it will find the service name is running with this. Now here comes the port number in picture. This port number is basically the port number where service is running. We explained here in here. This port is basically the port where service will be running, and target port is basically the port where pod is running. Pod is exported like that. So here again ingress. So I'm going to create this simply. To create this kubectl, apply -app. Maybe what is the name of ingress? App ingress. Okay, let's see. On the resources, comma ingress, pod SDC ingress. So it will display all the resources of default namespaces. So we have each pod connected to each service, and then app ingress is talking to these services. All these. So it's basically connected to all these services. So basically it's like that. This one. This ingress is connected to these three services, and these three services further talking to this pod. Why we have need of this? This is a very important concept. So this is something like a standard deployment I have explained you here. The only difference is like in production, you will see one more like deployment or HPA. So here it depends on you. If you want your services to expose to pod, then you have to mention in the command line here. Here export deployment or pod. That way it will talk to your deployment or the pod. So one more layer will be added only. So this is a standard deployment in any company for any application, sample application. So moreover, it can happen like an application, one application is running one namespace, second is running on second namespace, but it doesn't matter. And namespace does not add boundaries actually for the communication. It isolates the application, but it does not add boundaries to the application unless we apply a specific network policies basically. So what is the need of ingress here? I created ingress here, and this is saying we have a host. If we use this host here, we don't need to use this way exporting this port forwarding. We can avoid this port forwarding concept because this is not safe. If we do like that red, it should be talking to the red application. If I do like a blue, it should be talking to the blue application. Now the important thing is why it's not talking like that? Like, why is not displaying these values here? It should be, because the manifest is saying this host, if provided with /red app, it should be talking to, it should be displaying in picture the red page. If it is blue, it should be displaying blue. This is something we have to troubleshoot. This is very important concept again. Let me see, the recording is on. Okay. Let me plug in my chart. Okay, so we are going to troubleshoot. So we have a standard deployment. I explained you where this is very important concept. To this part we have configured. Now we will talk about what is the need of ingress managed load balancer here. You can see lots of diagrams, such kind of diagram. Let me just show you. Ingress controller and nginx and service mapping, something like that. Mapping. You will see like how these are related. Is go to images like that. You can see here, like there are lots of things you can see. There's incoming traffic, there's an ingress controller, an ingress resource basically, and then service, like I explained you. Lots of diagram you can see. So somewhere if you see the ingress here, nginx ingress controller. So any, doesn't matter what is the cluster type. If it is a, this is just Kubernetes cluster type. My object to demonstrate you here, like you understand what is the need of nginx controller here. So basically here, what is the need of nginx ingress controller? First of all, I have to allow Minikube enable. I think this is command I mentioned here. I don't know, this is command ingress. I will recall this. So this command is basically allowing you to enable the ingress controller. So let me recall quickly. We have created pod, we have created service, we have created ingress. The need for creating pod is just to deploy an application. We have created deployment as well. The need for deployment, to create deployment, is because by deployment we can manage pod easily in terms of patching, in terms of replica control, and yeah. And then we created service. Service we created because we wanted our pods to application to talk to front end or back end user, but it was not working because we, in our local, we have to port forward. But port forward is not a good concept as per security and compliance. That's the reason we have to further create our ingress. Now ingress is something which is allowing us to map resources for forwarding. So basically it's just managing traffic. If something is coming on slash path, so slash pod slash red, then the traffic will be forwarded to the red application. Blue slash path, blue slash blue, then it will be forwarded to blue slash default, will be forwarded to blue. That way the traffic for a specific application can be forwarded to the specific by a specific path. So those rules we have to define in the ingress file. And one common host name, we can pass this to the host file here. This guy here. And the port we have to remember, these are the port for services, and we have to note down that these services are actually running with this port, that we can just simply see. Yeah, here this services let's see hyphen o wide. So with hyphen o wide option, you can see actually these pods are running, services are running in a specific port. So this port is basically the port basically the port where service is running. Okay. And internally it's talking to the port with 80 port, or maybe 80. We have to check that here. Now ingress is here. So ingress is here having this address and this now this is important. Class I mentioned you here in the ingress. This is important annotation. So coming back further, one step back. So I was just trying to explain you what is the need for nginx ingress controller. So like I created these many resources, and each have its own requirement in a standard deployment of application. Sometimes you may not see ingress. It is not mandatory. The the thing is you should be able to manage the routing by any concept. If there's another method to manage the routing for a specific application, you can do that by another logic. So it depends on the users, like if you want to create a specific URL for a specific application, if he want to use the same URL but with path, then it can be done with an ingress. So it depends on the user's requirement. Now, what is the need of nginx ingress controller here? Ingress is a different resource of Kubernetes. Nginx ingress controller. Ingress controller basically is something a HA proxy. We have a HA proxy or nginx ingress controller. For there are lots of controller provider in market. Like there's one HA proxy and another one is nginx. Both are easy. We can deploy those as a pod. We can those deploy as a service. Like we can just simply install nginx service systemctl yum with yum package enabled with systemctl, or we can even deploy this as a pod. It depends on the requirement, and this either it is nginx brand or it is HA proxy brand. We can choose any of the controller type. So here in Minikube have the feature. It already allows provide you to like provide a command you to enable the nginx ingress. So once I run this command, it will enable the ingress nginx controller. So basically what will happen, this layer will be added, nginx ingress controller. Now the important part is why we need nginx ingress controller over ingress. Up to ingress we were cool, like we have deployed application, we have created deployment service ingress, we have understood the need for each. Now why we need ingress nginx controller or HA proxy type ingress controller? The requirement is simple. We cannot access application directly in browser in anywhere. We cannot access API in a specific user's laptop. So there are lots of certain things that comes in picture. Ingress controller basically helps us to do netting. Like if I open this here, hello, what here, this one, hello world dash info. This is just a host name and it is associated with this private IP. It is not a public IP. It is with a private IP. If I open this in the laptop, it's not going to understand, the browser is not going to understand this because it has not enabled the netting. So it nginx ingress controller helps in doing netting. So it maps with the public IP to the private IP, and by that we will be able to access the front-end API. Well, one thing. Second thing is security. So this is just basically a layer. This is just like it works as a load balancer also. It works as a HA proxy also. It works as a like the the need of proxy. So it proxies the IP, whatever we are searching, and it forward that to the different IP that is running inside the cluster. Basically, there are lots of benefits of running this nginx ingress controller or HA proxy type ingress controller. So, and like I said, netting, security, port forwarding, IP forwarding, and secure again compliance is like that. Load balancing. Okay, so again coming back, I have this enabled. There are lots of method to install the ingress controller. Like we can do by installing by pod. There are certain Helm repository. We can install this nginx controller. Now as soon as I enable this, actually it is Minikube is creating get pods ingress service SA secrets and hyphen ingress. Let me do that, ingress nginx. So basically, as soon as I run this command enable, this Minikube is automatically going to create a ingress, is going to create in nginx ingress and all the resources required for that. So this is done automatically. This is a good feature of Minikube. Else you have to manually download a Helm file for that and apply that simply. So now we were talking like why our blue this concept is not working as per the definition, as per the like standard scenario of deployment. This should be working for each path. Why it's not happening? Let's dig out. Kubectl will get pod as we see, and then ingress again. First of all, my system is not knowing sudo /etc/host. My system is not mapped with this host name. Hello world. Okay, it is there 192.168.49. Enable the here. When we enable the ingress here, we have to also create a tunnel. Basically, this is for local case scenario. For standard server deployment, it is not like that, because this is always open. So with this we are simply doing like we are allowing the ingress IP, which is to talk to the local environment, and this we already have mapped to the host. So simply you don't need to do anything, you simply enable the ingress controller, and then you see here we have the RAD. Now this is actually reaching somewhere to the application. Now there comes the lots of troubleshooting that we will continuing in the next part. So in our next part, since this video is going to be very long, in the next part what I'm going to continue is we will be continuing to explain like how this flow works when we create a pod. What are the error types that we can troubleshoot? Like I explained you, 502 is service error code. And then how we can see the logs here. One cover in the next part, all the error states. How can we fix this error state? How we understand those error state, the flow, API errors, like what are the front end facing, what are the errors we are facing. Until now, we have just simply created our base infrastructure so that we can use it to troubleshoot the next level. So this will completely cover all the questions related to troubleshooting. This is something maximum happening in any industries and company. There's nothing more than that. This is happening in terms of troubleshooting, or any interview can ask you. Anything that will come definitely will be coming from these parts only. So I hope the next class is not going to be too long. So we'll see you in the next class. So I hope till now we are good to understand, like we have just simply created pod, understood the need of deployment of, or need of pod, need of service, need of ingress, need of ingress controller, how this is mapped actually. So thanks for this class. I will see you in the next class. Bye everyone.